Okay, here's the solution of problem number 2. This is done by group number 4. Good job, group number 4. All right, so and here's what was given. You were given these time versus velocity data. And here's one thing I like. I like how they expanded, like had one data table. So that's good. So here's their solution. Then they had to graph velocity, and it looks like that's velocity right there. Velocity, you had to graph velocity as a function of time, and here's their velocity as a function of time graph. Okay, at 0 seconds, it starts at 2. Looks like every second we're increasing our velocity by 2 meters per second. And so there we go. So that's in green right here. That's your velocity versus time graph in green. We're going to talk about all this stuff underneath here in just a second. So that's part A. Now part B, you wanted the mathematical model. And here it is, right here. Should have labeled it part B though, but that's okay. They all got it on one word. So if you think y equals mx plus b, v equals, well, here's your slope. Here's your slope. Your slope is increasing. That is, we get a rise of 2 meters per second every second. Okay, that makes sense to everybody? That is our slope. Our horizontal velocity represents time. And when time is equal to 0, our starting velocity is 2 meters per second. So there you go. There's the mathematical model for velocity as a function of time. Now, we have to graph the position. Or actually, this is really, you can think of this as a delta x versus time graph. But delta x is x minus x initial. We're going to assume that x initial is the origin. In other words, our starting position is the same thing as our origin. At 1 second, we haven't had time to go anywhere yet. So we're going to start here. At t equals 0, our position is 0. Now after 1 second, look at this graph right here. After 1 second, how far did we go? Well, if we had gone 2 meters per second for 1 second, we would have gone 2 meters. This area right here represents my displacement because I started off going 2 meters per second for 1 second. But during that second, I increased my velocity. I went from here to here. So this area here represents how far I went because during that second, I increased my velocity. And what is the area of a triangle? 1/2 the base times the height. The base is 1 second. The height is 2 meters per second. So 1 times 2 divided by 2, because it's a triangle, is 1. So it represents 1 meter. So we went 2 meters because we had starting velocity, and we went 1 meter because I increased the velocity. So at 1 second, I have gone 3 meters. At 1 second, I've gone 3 meters. Everybody, is that clear? Now, during the next second, I start off going 4 meters per second. And if I went 4 meters per second for 1 second, I would go 4 meters. So this little rectangle right here represents 4 meters of displacement. But during that second, I increased my speed from 4 to 6. So I went this far. The area of this triangle represents how far I went because I increased my speed or my velocity during that 1 second. So the total area underneath here is 4 meters plus 1 meter is 5 meters. But I'd already gone 3 meters. So you have to add it all up. 3 plus 5 is 8 meters. At 2 seconds, I've gone 8 meters total. Is that clear as mud? Maybe even clearer? Any questions? Okay, in the next second, started off going 6 meters per second. So that's 6 meters in that 1 second, plus an additional meter because I increased my speed. So 7 out of the 8 is 15 meters. Now I was going 8. 8 for 1 second is 8 meters plus the 1 because I increased my velocity. So that's a total change of 9 meters. 9 meters plus the 15 I started with is 24 meters at 4 seconds. And then finally, I started off going 10 meters per second for 1 second. It's 10 meters plus the 1 meter due to the increase in velocity. That's 11. 24 plus 11 is 35 meters. Now I can check that. This is a trapezoid from here. This makes a trapezoid. Think of this as a base, and this is a base like a trapezoid on its side. So this is 12 plus 2. Remember, the average base times the height is the area of a trapezoid. So 12 plus 2, 14 divided by 2 times the height. 7 times 5 is 35. Bingo! We did it right. Now we have to graph it. Make this graph big and beautiful, because we're going to use it in the next assignment. 0, start at 0. At 1 second, we're at 3. At 2 seconds, we're at 8. 3 seconds, we're at 15. 4 seconds, 20, here's 25, a little under there, 24, and then this. And it should make, if you use graph paper, I mean, it's just a whiteboard here. If you use graph paper, this should make a nice, smooth, paraboloid kind of ish shape. Okay? So check your work with that. Star and question mark each part. Okay? Don't forget to star and question mark your work. That is all.